discussing the Gauteng next paper 1 for the June examination. Okay, so according to this paper, it was a paper that was out of 120 marks and done in 3 hours. And the first question in itself, okay, these are the instructions before we go to the questions. We have 8 questions and we need to answer all of them. We need to number the questions correctly according to the numbering system of the paper. Clearly show all the calculations, graphs, diagrams that might be used to determine the answers only, no marks, and so on and so forth. Okay, then we have our first question. Question number 1, where they are telling us to solve for x. Okay, so we're given 12x is equal to x squared, and then they want us to solve for x. So the highest degree in this expression is 2. So which forms a quadratic. So for us to solve this, we need to create a standard form in the first place. So this would be this, if I move the 12x, that side is going to be the same as x squared minus 12x is equal to 0. And then from there, I can see that x is common, so I can factorize out the x and say my x is common. I'm going to be left with x minus 12 is equal to 0. And then I can use my dot product to solve this equation. So this first x is going to be greater to 0, or the x minus 12 is going to be greater to 0. So if I solve this one, which means my x is going to be 12. So that question is just 3 marks. 3 marks. Then we have 1.1.2. They're telling us hence or otherwise, can we determine the values of p? If p squared minus 1 squared is equal to 12 times p squared minus 1. Okay, so the word hence simply relates to where we stopped in the previous question, or from where we stopped, can we proceed or use the information that we obtained in the previous question. So when I look at this and compare it to the original question, if this is p squared minus 1 squared, it's as good as someone saying this is x squared, because I see a 12 here and I see a 12 here, and then this is the x. So which means I'm going to let, okay, this is 1.1.2. I'll let my p minus 1, p squared minus 1 to be x. Okay. So the question is telling us that if we have on this side, it's p squared minus 1 squared is equal to 12 into p squared minus 1. So if p squared minus 1 is x, what answers did we get for x? Okay, remember from our previous question, we said x is a 0 or x was a 12. Okay, so if that is true, and I'm saying that p squared minus 1 is that, so I'll start by equating the x to be a 0. So I'll have p squared minus 1 being equal to 0. And then I'll transpose the 1 to that side. So p squared is equal to 1. And then I can find my square root, or I can use the difference of 2 squares at this stage and equate to 0. So which means my p is a plus or minus 1. Okay. Now what if I represent the p squared minus 1 and replace it with 12? Move the 12, the one that side is going to be p squared is equal to 12 plus 1. So p squared becomes a 13. And then I find the square root. It will be plus minus 13. So that will be the answer, or those will be the answers for my 1.1.2. Then 1.2, they want us to solve this. Remember, if we are rounding the answer to decimal places, we have to use the quadratic formula. So it's 5x squared plus 7x minus 2 is equal to 0. So what we said was that determine what is your A. Our A is a 5, our B is a 7, and then C is negative 2. And then we say that from the quadratic formula, negative B plus minus square root of B squared minus 4AC. We're dividing it by 2A. We do the substitution, so that's a negative 7 plus minus, this is going to be 7 squared minus 4 times 5 times negative 2. Everything is divided by 2 times our A, which is a 5. Okay. So if I punch that into my calculator, so this will be it. So remember I said use one sign at a time when you're substituting within the calculator. Okay. So if I use square root of that minus 3 over it. So I'm having 0.24. Okay, or my x, if I use the minus sign in between, I'm having negative 1.64. So this is the first answer, and then that will be the second. So that will guarantee you all the formats for 1.2. Okay, then 1.3. 1.3, they are telling us to solve for x if the square root of x plus 6 is the same as x. Remember, with such questions that have square roots, we said isolate the root sign. In this case, it's already isolated for us. So all we need to do is just move on to the step of squaring both sides so that we can get rid of the root sign. Okay, so that's going to be square root of x plus 6 is equal to x. So we said we square both sides. Okay, this square throws the root sign. So we have x plus 6 is equal to x squared. Then we create the standard form. I'm going to move everything to the right. So it's x squared minus x minus 6 is equal to 0. Let me just make this clearer. Thank you. So x squared minus x minus 6, because when this x transposes that side, it's a negative. When this positive 6 moves that side, it's also be negative. Then from here, I have my quadratic. I can use the factors, or I can just use the quadratic formula, whichever one works for you. So this is going to be x and a 3, x and a 2. I'm going to make this a negative, the plus. Okay, which means either x is a 3 or x is going to be negative 2. Remember what we said also, that whenever we have root signs involved, it's always advisable to test our values against the left and then the right-hand side to make sure that we have the same answers, okay? So if I test the 3 on my left, let me use this, okay. On my left-hand side, if I use 3, that will be 3 plus 6, which is 9, and then square root of 9 is 3, which is the same as the right-hand side. Okay, so right-hand side is 3, which means that one is fine. But if we try with negative 2, if I put negative 2 into the square root, so negative 2 plus 6 is going to give me square root of 4, which is a 2. But then this 2 is not the same as that negative 2. Remember, our original x is negative 2, which is this. So 2 is not the same as negative 2. So in our conclusion, we can say that therefore, x is a 3. We can cross this out if you want. All right, so that is 1.3. Then 1.4. 1.4, they want us to use the solution that we got in 1.3. So we're going to use the x is equal to 3 to determine the values of y for which This is equal to that. What are they saying? This is equal to that. Okay, so from what I can see, there's a square root sign, there's also a square root sign. So which means x plus 6 is the same as y plus 1. And then x alone is the same as y minus 5. So what I'm going to do, I'm just going to replace x with y. So I'm going to say x is the same as y minus 5. Okay. So if x is the same as y minus 5, the same, x is the same as y minus 5. But we got our x as a 3. So I put a 3 there is equal to y minus 5, and then I'll move the 5 that side. It's going to become a positive. So which means my y is going to be 8. I think that is it. Even if I try to use the other one, where we have the x plus 6 is equal to y plus 1. So if x is a 3, that is 3 plus 6 is equal to y plus 1. So 9 is equal to y plus 1, move to on that side. So y is still an 8. So whichever option we take will be acceptable. And then 1.5. They're telling us that a race requires an athlete to run 10 kilometers, and then you have to cycle for the 50 kilometers. Tembani runs at a speed of x kilometers per hour, and then decides to cycle at the speed. It takes 10 over x hours over 10 kilometers. Express the time that it takes for the 50 kilometers in terms of x. Okay. Express the time it takes for the 50 kilometers. So if I'm to split this thing into 2, because we have the cycle and then the running. The cycle is going to be 50 kilometers. The running is 10 kilometers. The speed is x. He runs at x kilometers. Okay, that is our speed, that is our distance. And then the speed here is going to be x plus 31. When we look at the time element, there is 10 over x here for the time. How much time is there? So from our speed, distance, and formula, speed, distance, and time, sorry. So we know that speed is distance over time. For us to get time, we must get the distance, we divide it by the speed. And so our distance is 50, and our time is x plus 31. So we're just gonna say that is 50 over x plus 31. Okay. So it's already in terms of x. Okay, then the next question, they're telling us that calculate the speed, correct to decimal places, at which he must run to complete the race in 2 hours. So if this was a 50 over x plus 31, if we combine these 2 times, they should be equal to 2. So if we can get the value of x, then we have the speed. We can just substitute that. So I'm going to say in 1.5.2 that the speed for running plus the speed for cycling must be equal to 2. Now, since the speed the time, sorry. Saying the time for running, it can't be the speed. So time for running and the time for cycling must be 2 hours. Okay, they gave us the time for running, which is 10 over x. Okay, so 10 over x plus the time we got, which is 50 over x plus 31, it must be equated to 2 hours. Then we can just eliminate the denominators. How do we do that? I can multiply this and this, or if not, I can just cross multiply, where I multiply this and that, this and that, this and that for the left hand side. So that is 10 into x plus 31 plus 50, and x is going to give me 50x over, I multiply these two, x plus 31 into x is equal to 2. And then I can again cross multiply. For as long as I have equal signs, it's just this and that, this and that. I can do that as I'm busy opening my brackets. So that's going to be 10x plus 310 plus 50x times 1. I'm going to get the same thing is equal to, this is going to be 2x into x plus 31. I'll simplify this. So 310 plus 60x is equal to 2x squared plus 62x. Okay, the highest degree is a 2. I can group everything to one side and create a standard form. So 2x squared, this is a 62. When I move this 6 to this side, it's going to subtract. So I'm going to have a plus 2x. When I move the 3 to that side, it will be minus 310. It's equal to 0. Then I can divide both all through by 2. So that is x squared plus x minus 310 divided by 2 is giving me 155 is equal to 0. Then I can use my quadratic formula to solve for x. So a is 1, b is 1, and then c is negative 155. Because when I look at negative 155 and 1, I can't find numbers that I can easily multiply, subtract to give me that kind of combination. So x is negative b plus minus square root of b squared minus 4ac over 2a. So that's going to be negative 1 plus minus square root of 1 squared minus 4. Our a is 1. This is negative 155. I'm dividing it by 2 times 1. Okay, so when I punch that into my machine, I'm having 1 plus that over that. So the first answer I'm having is 11.96 seconds. Is it seconds or hours? It's hour. Okay, also 11.6. Remember, it's x now. What does x represent this side? X is the speed, which is 11.96 kilometers per hour. Or if I changed my sign to minus, then I'll have negative 12.96 kilometers per hour. Okay, so but we know that speed can never be negative. So in most cases, we're gonna eliminate the negative answer and just focus on the positive. So if our x is 11.96 seconds, what was the question asking for? Calculate the speed at which you must run. Okay, and that is the run. I think the speed for running is x. Okay, so I think we've answered the question correctly. So we can say that therefore, this guy must run at 11.96 kilometers per hour. Done. Then question number 2. They're telling us that in a geometric series, so we know that in a geometric, that's where we have a common ratio. So the sum of the first n terms is given by this formula, and the sum to infinity is this. Okay, so what is important is the sum to infinity. And for this, okay, they want us to get the values of, okay, that is for maths. So what do we know? We can start by finding the terms themselves. Does that make sense? Determine the values, okay. So there's some bit of simultaneous. All right, let's see. So we know whenever we are given the sum of an expression that Sn is given by k into 1 minus, let's say, a half to the exponent of k. So one thing we need to know is that when you talk of S1, the sum of the first term, that will be the same as our T1 or our A. Okay. And then for us to get the sum of the second term, if this makes sense, okay, I can find my first term and then apply the sum to infinity, 1 over that. But I'm gonna need S2 minus S1 must give me TP. And I also know if I get S3 minus S2, I will get my T3. I don't know, I can start by finding S1 and S2. Okay, so I'll say that my T1, which is the same as S1, I'll replace 1 into the formula. So that is K into 1 minus a half the exponent of 1. And that will give me a half K. Okay, so that is a half K. That is my first term. Let me try to get my second term for my S2. My S2 is going to be K into 1 minus 1 over 2 squared. Okay, so I know that 1 minus 1 over 2 squared, that's going to give me 3 over 4K. Okay, but remember, for me to get my second term, I must get 3 over 4K. I subtract the first term, which is a half K. Okay. And then I'm getting 1 over 4K. So this is my first term, that's my second term. What is my common ratio? So the common ratio, I need to do this. You can tell what it's already half from the someone who said how. Let's see. If you get 1 over 4, and then we divide it by a half, we end up with a half. So I put a K divided by a half K, it gives us a half. So the common ratio is constant, it's given to us, which is a half. Then what I need to do is just substitute into the sum to infinity and say that my sum to infinity is A over 1 minus R. So 10 is equal to A. Remember, our first term is a half K. So a half K over 1 minus just a half. Okay, and then simplify this. So that's gonna be 10 is equal to a half K over 1 minus that, you get a half. Multiply both sides by a half. So 5 is equal to a half K. And then I'll need to multiply both sides by 2. So K becomes a 10. K becomes a 10. All right. Then with question number 3. With question number 3. Yes. Okay, 3. Oh, is that? Oh, did we skip a question? No. Skip the question, guys. They want us to calculate the second term. So since we've gone through a long way to simplify all of this and all of that, remember, since we already have K as 10, which means our Sn is the same as 10 into 1 minus a half the exponent of n. What I told you, for you to get the second term, you must get the sum of the first two terms minus the sum of the first term. But we had already simplified that to 1 over 4k as our second term. So we could simply substitute that. We could simply substitute into that, and where there is k, we just put a 10 without necessarily going through that whole thing. So I'm just going to say that my T2 is going to be 1 over 4k, which is 10 over 4, which is the same as 5 over 2. I could do it this way. Or I could go through all of that effort, but I've already done it, so I don't need to repeat that. Then with question number 3, prove that in any arithmetic series in which the first term is a and goes constantly fixes c, the sum will always be given. That's that. Interesting. Okay, so with this, you're proving the sum of an arithmetic. You need to know, how does it work? Okay, how is it work? So we shall say that 3.1, for us to prove the sum of an arithmetic, we shall say that if the sum of any progression is n is given as, let's say, a plus, because this is the first term. Our second term is going to be a plus d. Our third term is going to be a plus 2d, and so on and so forth. Because it's an arithmetic, we just keep on adding d. It's only difference. And then we can have our last term as a plus n minus 1 into d. Some people prefer using the letter L, no problem. Then what if we switch this equation this way, so that the last term comes first and then all of that. So our last term here is going to be a plus n minus 1 into d. And then we're going to have terms somewhere there, and then our first term becomes last. And then we can plus the 2. So Sn and Sn will give us twice Sn. I'll just plus this first one, so that's going to be a plus n minus 1 into d. In other words, I'm just adding this first term together with this first term. You can do the same here, and then you see that the results you're going to get are going to be just the same. Okay, so there's no need of us doing all of that and repeating the entire process, because it's just the same thing. Okay, so now when I'm talking about, let's say, n terms, or a certain number of terms that I don't know, I'll multiply this by n. So 2 or twice Sn is equal to n into, I can simplify what is inside the brackets, that's 2a plus n minus 1 into d. Then I can divide both sides by 2, so that I have n over 2 into 2a plus n minus 1. So that's how I would prove that. Okay, and then 3.2. They want us to find the value. Okay, the value of this. So whenever we have sigma notation represents the summation or the sum of any progression. Now we need to first of all know what sort of progression is this. Is it arithmetic or geometric? Okay, we can know that by just simply substituting the values of p or the unknown into the given format. So if p is 1, what will this register? It's going to be 100 minus 3, which is going to be something like 97. And then if p is 2, that will be 100 minus 3 times 2, which is 100 minus 6. And that will give us a 94. And then if P is 3, that will be 100 minus 3 times 300 minus 9. That is going to give us 91, and so on. So 3 terms are just enough for us to determine what sort of progression it is. So from here, I see we are subtracting the term. So that is an arithmetic. Okay, it's an arithmetic whereby our first term is 97, and then our common difference is -3. Okay. Then we know that the sum of an arithmetic is given as that 2a plus n minus 1 into d. Remember what we just proved now. So how many terms are we talking about? We're talking about 50 terms. How do we know that? Okay, the upper limit minus the starting limit plus 1. So that is 50. Okay, so that's going to be 50 over 2 into 2 times 97 plus, that is 50 minus 1 multiplied by -3. Okay, so I have that. Given the nature of the marks, or given the number of marks that are there, I don't need to really dwell much onto breaking this down. What? No, just punch that into a calculator. So 2 times 97. Oops, I need a big bracket. All right. Plus, that's gonna be that close bracket. I'm having 1175. All right, so that is question 3.2. And then 3.3. 3.3, they're telling us that a quadratic sequence is defined by the following properties. Number 1, if you get T2 minus T1, you get a 7. If you get T3 minus T2, you get a 13. T4 minus T3, you have a 19. So these are more or less the first differences. Okay, whereby if we have T1, T2, T3, and T4, what we have here is a 7. What we have there is a 13. What we have there is a 19. Then the question is asking us to write down the values of T5 minus T4. What's wrong with me? This is a T4. So we expect a T5 to be. So since it's quadratic, we know that the second difference must be the same. So what is 13 minus 7? That is a 6. That is a 6. So which means 19 plus 6, that's going to be 25. So we're going to say that is 25. Okay. And then when we look at T70 minus T69, then we need to get the Tn of this pattern. But since it's arithmetic, okay, since it's arithmetic, we need to find the Tn, which will be given as a plus n minus 1 into d. So our a is a 7, and then our d is a 6. If we try to simplify this, the Tn is going to be just 6n plus 1. Now, when you're finding T70 minus T69, they are indirectly asking us to find T69. Okay, so that's going to be 7. Okay, I don't need to use that since I've already simplified it. Okay, so that's going to be 6 times 69 plus 1, and that will give us 415. Then 3.3.2, calculate the value of T69 if T69. There was an error with this question. Doesn't make sense. There's no way we can find T69 if they've already given us the value of T69. Okay. Then we're going to move on to 4.1. Question 4. So we're given x squared minus 2x minus 3, and then we have g of x. So these are functions, no? So with the functions, we need to know the type. So x squared, this is a parabola. Okay. And x minus 5, this is a straight line. So they want us to show that the turning points of f. Okay, so how do we get the turning points? Remember, for turning points, we said you must get the axis of symmetry, which is negative b over 2a. Okay. Then my b is negative 2. So that's going to be negative and negative 2 over 2, but my a is a 1. Remember, a is the coefficient of x squared. My b is the coefficient of x, then my c is negative 3. You substitute that, I'm having a 2 over 2, which is a 1. Okay. If it's 1 as our answer, then we just need to replace this 1 into the equation. So I'll say f of 1 is the same as 1 squared minus 2 times 1 minus 3. Okay. So we're saying 1 minus 2 times 1 minus 3. And then our answer becomes negative 4. So just show how you get that. Please don't be like those learners that just write the same answer there without showing any calculations. 4.1.2, they want us to determine the coordinates of the x and y intercept of f. Okay, so x and y intercept. So we know that are the x-intercept. Okay, y will always be 0. So we know that f of x, g of x, h of x, whatever, represents y. So where there is this f of x, we're going to put a 0 and then solve for the equation. So that's going to be the same as x squared minus 2x minus 3 is equal to 0. Okay. If we try to solve that, okay, if we try to solve that, I will just open my brackets, or you can use your quadratic formula. That's x minus 3 and x with 1 plus 1. Makes sense? Okay, yeah. So I'll equate that to 0. So in this case, x is going to be a 3, or x is going to be negative 1. So these are the x-intercepts of f. So how can I write that? I'll say it's 3 and 0, and then negative 1 and 0. Okay, those will be the x-intercepts. Then for us to get the y-intercept from a parabola, then constant number, constant term, this negative term, we don't even need to calculate it. Okay, so we're saying y-intercept, x will be 0. When you replace a 0, you get negative 3. So that's going to be 0. Then they want us to determine the points of intersection of the graphs f and g. So one thing we need to know is that points of intersection are points where the two graphs are equal to each other. So g of x will be equal to the f of x. Okay, so we're saying it's a point where the two graphs should be equal to each other. That's the point of intersection. So all you have to do, solve the two equations simultaneously, or just equate those equations to each other, since they are usually in the form of y is equal to that and y is equal to that. So when I look at my g of x, which is the straight line, the equation is x minus 5. Should be equated to x squared minus 2x minus 3. And then I just need to create a standard form. So I'll move everything to one side. So x squared minus 2x minus x minus 3 plus 5 is equal to 0. Simplify that. So it's x squared minus 3x. That's going to be a plus 2 equal to 0. When I use my quadratic formula or my factors, I have x and x numbers I multiply to give me 2 will be 2 and 1. If I make them negative, I have a positive addition to get 3. So it's either x is a 1 or x will be a 2. Okay. So these are just the x coordinates or the x values. We need to find the y values. So with the y values, we can use any of the equations. I would prefer to use this one because it's a simple one. So y is going to be 1 minus 5. That's going to be negative 4. So y is 2 minus 5, which is a negative 3. Okay, so remember, this is more like the simultaneous question that was never asked in the question. It has come here indirectly. All right, then 4.1.4. They want us to sketch f and g on the same set of axes. We must show the intercepts and all of that. So one thing we need to know, we don't have the intercepts of g. Okay, but we know that the y-intercept is going to be negative 5. How about the x-intercept? So x-intercept is going to be, so if I put this to 0, then it's going to be 5. 5 and negative 5, that's a gradient of 1. Okay, so that's all we need. Sketch it somewhere. It fits with people. Okay, let me just push it and see if I can squeeze it here. So I'll have my y-axis. Okay. And then I can this to be the x-axis, which is okay. That is my 0, 1, 2, 3. That even makes sense. Trouble. Okay. So I'll have something like this. I don't need to. It's okay. So for the intercepts of the parabola, we say there's a 3 and negative 1. So either way, I have to. That's a 3. I can put negative 1 somewhere there. It's logical enough, but it's fine. Okay. Then y-intercept, we say this is a negative 3. So if I put a negative 3 here, okay. And then my turning point, remember the first question asked us for turning point, which is 1 and negative 4. So if 1 is somewhere here, negative 4 can be slightly below somewhere here. All right. I think I have that. I have my intercepts there, then my turning point. Then I'll just, let me try. Okay, so that is my f. Okay, so as long as you indicate the negative 3 for the intercept, the negative 1 for the x-intercept, and all of that. So this is a 1. Then we go to the straight line. With the straight line, we said the x-intercept is 5. 5 can be somewhere there. Does it make sense there? Is it making sense? So x1 and x2. So which means okay, that's fine. Which means I have to just remove that so quickly. What's this? It's a paragram. No. Okay, so if that is my 5, remember this is our 4, so 5 is somewhere here. So a line that will connect somewhere. straight line, that's a job X. They will be meeting somewhere. It's at a point of 1. Remember from our values, I will say that 1 and 2, that's when the graphs meet. And I'm assuming this is my 1, and then that is also my 2. At least there has to be an intersection. Okay, guys, so that is our graph, or those are our graphs. Then they're asking us to use the graph to determine the values of X for which f of X is greater or equal to 0. Okay, so f can be greater or above 0 when everything is positive. Okay. In other words, where do we find it above the x-axis? So what I'm seeing is that the area to the right, which is this side, and then the area to the left, that side, it's above 0. It's above or equal to the x-axis. So what I'm going to do, I'm just going to look at the points where the graph is meeting the x-axis. So I'll say my x is greater or equal to 3, or my x must be less or equal to -1. Because below -1, the graph is above the x-axis. And then above 3, the graph is also above. So those will be my 2 solutions. All right, so that is 4.1. Removing 4.2. This is f of x is equal to 1/3 to the exponent of x. So this is an exponential graph, and it's already sketched for us, okay? Then they want us to write down the equation of the asymptote. So asymptote, remember, is a point where the graph cannot cut, okay? And in normal cases, if we have a to the x plus q, this q represents the asymptote. But if the question does not put a q there, so there is automatically a 0. So the equation is going to be y is equal to 0. Okay. Then 4.2.2, they want us to get the equation of the inverse, f -1. So with this, don't stress, guys. Remember, if it's exponential, the inverse must be the log. Okay. So if it's a log, remember 1/3 will be our base. So just say log, okay, 1/3 to the x. So y is equal to the log 1/3 to the x. And that is our inverse. Then 4.2.3, they want us to sketch the inverse. In your answer to indicate at least one intercept and one other point. So remember, okay, I'm just going to use this same graph. If this is x, okay, so if x is 0, I'll say at x is 0, that's our y. The whole thing will be just a 1. So in other words, this point here is 0 and 1. When I'm drawing my inverse, the point that was 0 and 1 will have to become 1 and 0. Okay, so which means somewhere here, if I have my 1 there, that's where the graph is going to pass. Since the x-axis was an asymptote, in this case, the y-axis is going to be our asymptote. So we can just sketch nicely as long as passes through here and just moves in that sort of direction. Remember, they said they want one more point, so just look for any other point. Okay. Let's say if x is a 3, why are we using 3? Let's use 2. Yeah. That's 3. So you tell us if x is a 2, that's 1/3. Okay. 1/3 to the 2, which gives us 1/9. Since it doesn't make sense. Okay. Doesn't make sense for me. Not at all, not at all, not at all. Because that is positive. And I'm using a positive value. So why is it negative? No. I'm sorry, I'm using the wrong thing, isn't it? So C1 above the answer, which is a 9. So it will give me a 9. Remember, y is it a third or a third to the x? For the inverse, we are changing. X is equal to a third of y. Okay? Third of y. So it's saying if x is a 2, that's for the sake of clarity. If x is a 2, it's not a 9, guys. I'm sorry. What's the meaning? It's negative 0.6. Negative 0.6. Something like that. If you put a negative 1 here, then it will become a 3. So it means that a 3, and so on. Remember, we just need 1 point. So we've sketched that. Then write down the equation of the asymptote of the inverse. If there is x plus 2, if there's a shift of 2 units to the left. So the inverse of the asymptote is going to be x is equal to negative 2. So replace that's going to be log 1 over 3 x plus 2. Plus 2. Since in the other direction, it's going to be negative 2. Then 4.2.5, can we prove that f of x squared minus f to the negative x squared gives us this for all values of x? So we need to look at this because this is a proof question. We need to look at the left-hand side and the right-hand side. So if I start with the left-hand side, what was my f of x? It was 1 over 3 to the x. So I'm going to substitute that 1 over 3. And this is now going to be to the x, that squared, minus, where there is x, I'm going to replace with the negative x. So 1 over 3, the negative x, that squared. When I simplify this, it's going to be the same as 3 to the negative x. And then I square that. I'm moving the 3 upwards so that it can have a negative 1. Then this is going to be, when I move that up, it's going to be 3 to the x, that squared. And I'm going to end up with 3 to the negative 2x minus 3 to the 2x. That's what I'm getting by the left-hand side. Let me try by the right-hand side. If I have f of 2x where there is x, I'm going to put 2x. Okay. I'm subtracting. Where there is x, I'm going to replace with negative 2x. So 1 over 3, the negative 2x. And I open this up, I'm getting negative 1 to the 2x minus, that is 3 to the negative 1 also, that's the negative 2x. When I open that, I'm having negative 2x on top, minus negative and negative. It's going to give me a positive 2x. So we see that this is that, this and that. And to a conclusion. Therefore, left-hand side is the same as the right-hand side. All right. Then next. It's question 5. Diagram below represents the graph of f. So we know that this is a hyperbola. This is a hyperbola. What do we know? We don't know the asymptotes. Yes, yes. But we have 5, we have 3. Okay. No, we know the asymptotes, guys. This is a 4, as much as it's faint. This is a 2. Okay, so we have our asymptotes. What do they want? They want us to get A, P, and Q. All right. So we know from the graph, Q is this line, the horizontal asymptote. So Q is a 2. No stories. What is our P? P is the vertical asymptote, which is a 4. No stories. Then let's substitute to get A. So our f of x is going to be A over x minus 4 plus a 2. Then we're going to use the point 5 and 3, because that's where the graph is passing to find the value of A. So that's going to be, this is x, that's y. So 3 is equal to A over our x is a 5 minus 4 plus 2. You know that 5 minus 4 is a 1. So 3 is equal to A plus 2, move the this one. Therefore, our f of x is just going to be 1 over x minus 4 plus a 2. All right, then 5.2. If the graph is reflected across the line of y is equal to negative x plus c, and then we have a new graph that coincides with a graph of y is equal to f of x, they want us to get the value of c. Okay. Negative x plus c. What is the value of c? So what the question is indirectly asking us for is for the axis of symmetry. But the axis of symmetry that is having the negative gradient, since the gradient is negative 1. So we know that axis of symmetry is normally given as x plus c or negative x plus c. And we normally use the intersection of the asymptotes. This is 4, that is a 2. Substitute that, get your c. So where there is y, I'll put a 2, and that is negative 4 plus c. Move the 4 that side, c becomes 2 plus 4, and then that becomes a 6. So indirectly, they wanted you to find the axis of symmetry. All right. 6.1. This is calculus. Okay. What do they want us to do? Given 3x minus x squared, use the definition from past principles to derive this. Okay. So 3x, just 3x minus x squared. So let's fix it. Okay. So guys, this is our f of x. No? We need to create what we call the f of x plus h. So where there is x, replace with all of that. So that is 3 into x plus h minus x plus h squared. And then we go on and substitute into the formula. We know that f prime of x is given as the limit as h tends to 0 for f of x plus h minus f of x. And then I'll divide by h. This implies that the limit as h tends to 0, let's substitute. And I replace that, that is 3 into x plus h minus x plus h squared minus the whole of f. I'll put them in brackets just for the sign. Okay. And then, is that too big? It's just fine. It's just fine. So the limit as h tends to 0, we shall have open the brackets, so 3x let's do this, plus 3h. So I'm opening this bracket. And then this is going to be negative. Remember when I open x plus x squared, this gives me x squared plus 2xh plus x squared. So let me just, okay, it's fine. I'll allow an extra step, x squared plus 2xh plus h squared. Open this up, minus 3x plus x squared over h. So we're saying limit as h tends to 0. That's 3x, 3h. I'll open this, minus x squared minus 2xh minus h squared minus 3x plus x squared over h. So at this level, some things must cancel. So this cancels that, this cancels that. I'm only left with 3h, negative 2xh, and then that. I have to factorize. So limit as h tends to 0, h becomes 3 minus 2x minus h over h. So this will cancel. But we know that the limit as h tends to 0, everything will reduce. Have 3 minus 2x minus h. So h is a 0. So which means we shall have 3 minus 2x. So that becomes our answer, our first derivative. All right. Then 6.2. 6.2. 6.2, they are telling us to find dy dx. So dy dx is more like the derivative. So in cases like this, first eliminate or first separate. So that's going to be x over x squared minus 3. We know that square root is the same as exponent a half. I'm still separating x squared. Remember, from our addition and subtraction of fractions, if the denominator is the same, then you can add or subtract the top part. So I'm still simplifying. This and that is going to give me x to the negative 1 minus, we know that half minus 2 is negative 3 over 2. Okay, so this is our new y. Now let's find dy dx. I'm just going to use the rules. So this and that will give us negative x. We subtract 1, we shall have a negative 2. This negative and the negative, we shall have a positive. 3 times 3 over 2, that's going to be 9 over 2. With x, if we subtract 1, we get negative 5 over 2. That's what I'm getting as. So since the question was not specific of positive exponents in most cases, just stop, don't stress. Then we have y over 3x is equal to 1 plus x squared. Just jot it down here. I'm saying y over 3x is equal to x plus 1 squared, or 1 plus x squared. It's the same thing, guys. Okay. So first make y the subject, so that it is 3x into x plus 1 squared. Open this up. That's going to be x squared plus 2x plus 1. By square brackets, we are foiling. Okay, x and x is squared. Then open this, simplify it. That's going to be 3x cubed plus 6x squared plus 3x. And then dy dx, 3 and 3 is a 9x. We reduce that to a 2. And then 2 and 6, that is 12x. Reduce that. And then that will reduce to a 3. So that becomes our final answer. 9x squared plus 4x plus 3. Now, guys, the order does not really matter. Okay, whether the 3 comes first, or the 12 comes first, or it doesn't matter. Unless if the question told you that you must give it in a particular form. 6.3. Okay, there is a function f that is given as x squared plus b over x. And this function has a minimum value of 12. if x is 2. Find the values of a and b. So whenever we talk about minimum or maximum under calculus, what must come into our mind should be the derivative. That is minimum or maximum. So one thing we also know is that at this point, the coordinates of x are 2, the coordinates of y are 12. Okay, that is number 2. Then going back to the derivative, we know that at the minimum or maximum, the derivative will always be equal to 0 if we replace the x as a 2. Okay, so what do we do first? I'm going to find the first derivative, just like I said. If not, I feel like that is what must be done. Ax squared plus b x squared plus b over x. That is my y or my h of x. Okay, then I'll change that so that I have x squared plus bx to the negative 1. So my dy dx being equated to 0 because I know that the derivative represents the turning point. And at turning point, the gradient is always 0. So that's going to be 2ax minus bx to the negative 2 must be equated to 0. But we know that at that point, x is a 2. I'll replace x with a 2. So that will be 4a minus, that's b minus 4 is equal to 0. Okay, so I can choose to make b the subject or make a the subject so that my 4a is the same as b over 4. Multiply both sides by 4 so that b is 16a. That is equation number 1. Then at a point where x is a 2, y must be a 12. Okay, remember it's part of the graph, 2 and 12. So I'm going to substitute 2 and 12 into this equation. Where there is y, I replace with a 2. That's going to be a into 2 squared plus b over 2. Okay, so 12 is equal to 4a plus b over 2. But what did we say b was? B was 16a. So that is 12 is equal to 4a plus 16a over 2. Okay, so 12 is equal to 4a plus 8a. 12 is equal to 12a. Divide both sides by 12, which means that my a is a 1. Does that make sense? Does that make sense? A is a 1. What was the question asking for? They want the values of a and b. Okay. Then I just need to replace this a into this equation 1, because this was my equation number 2. This was equation number 2. Okay, so which means b is going to be 16 times 1, which is a 16. So guys, that's what I get. A is 1 and then b is 16. All right, we move, guys. We move. That was 6.3. 6.4. No, we don't have 6.4. It's just question 7. Okay. It's just question mark 7. Okay, question 7. Still calculus. Are telling us that the graph of a cubic function f has the turning point at this a and then at that point. And then the graph has the following properties. The first derivative is greater than 0 between -1 or between x being less than -1 and x being greater than 2. Remember, these are the points here. Then the first derivative of x is less than 0 where x is -1, less x, less 2. So this interval. And then our f of 2 is greater than 2. Let's interpret this lines. First derivative, remember we say the gradient. So the gradient is greater than 0. In other words, it's increasing. Okay, where x is less than -1 and where x is greater than 2. Then the first derivative or the gradient is decreasing within this interval of -1 and -2. And then f of 2 is greater, is above 2. So what I can kind of get from this, remember, we have two types of cubic function graphs or cubic functions. We have one in that sort of format. Okay? And then you have one that is in this sort of format. Now, with the first one, first option, this is the skeleton. With the first option, if they told us the turning points at -1 and 2. So if I call this my -1, and this is my 2, okay? For x greater than 2, the graph is increasing. You can see that the gradient is positive. And for x -1, the gradient is still positive. But between -1 and 2, between these intervals, the graph is decreasing. So it's a negative. Okay? Then they are telling us that the y value where x is a 2, it must be greater than 2. So which means if I were to have this, so I already know I don't need to consider this, since this one just perfectly brings about the type of graph I want. Okay? Now, the problem is now, where do I put the turning points? Above the x-axis or below the x-axis? So I know that if this is my 0, the last point at a point of 2, it must be greater than 2. So which means if this is my 2, the graph must be slightly above 2. So it is not cutting the, what we call it. So which means I can have something like this. Okay. And something like that. I don't know if it looks like a cubic function, guys. It's a sketch. Okay. It's a sketch. Someone's going to complain. It's a bit. Why is it like that? Maybe people will be happy with this. Guys, we are just interested in the turning point or a turning point. So this is going to be our A, since it's on the negative side. And then this is going to be our B, which is 2 and 2. They told us it is above 2. It's greater than 2. And this is slightly above. So that is the sketch. So someone asked, how is this marked? So look at the shape. Okay. Is it the increasing, the decreasing? You look at then the different parts. This part of the gradient, this part of the gradient, and that last part of the gradient. Sometimes when you look at the points, is this one above the 2? Then will be the ones, if you deserve them. All right, so that is 7.1. Then 7.2, we have f of x being x cubed plus bx² plus cx plus d. They want us to calculate the values of b and c. Now they're talking. They are now talking. All right, what do we know about this? What do we know about this? What information do we need to answer a question of this magnitude? Okay. So we're saying ax squared plus bx, and it's x cubed. A plus zeta c x plus d. Just a random question like that. But it relates to the information we have earlier on, because it's also F. So remember, our A is negative 1 and 2. And then our B is 2 and 2. Don't forget that. Okay. So since these are turning points, which means we can get the first derivatives. Okay. That's what I'm noticing. Remember, the only one is it C and D or B and C? It's B and C. What B and C? D the differential. Okay, guys, any ideas of what should be done? Because if I find my first derivative and equate it to 0, this should be roots of the first derivative. Which means if I substitute the negative 1 and the 2 into the expression, the first derivative, I must get a 0. It's okay, let's see. Since this D doesn't have x as a constant, okay, then it makes sense. So that's going to be 3x squared plus 2ax plus what's going on? Where is a coming from, guys? No. Something's amiss. You are supposed to be P. It's not A here. So this one is also disappear. Guys, I apologize for that. Okay, something is. So which means we don't have this. It's just gonna be a C. Remember, we are equating it to 0. Which means I'm gonna replace x with negative 1. Replace x with a 2. And say x is negative 1. That's 3 negative 1 squared plus 2b times negative 1 plus c is equal to 0. And I simplify that. It's going to be 3 minus 2b plus c is equal to 0. Okay, I can next see the subject by moving everything outside. It's going to be 2b minus 3. Do the same thing. F prime of 2. So that's going to be 3 times 2 squared plus 3 times 2b plus c is equal to 0. This is 4 times 3, that's a 12, plus 4b plus c is equal to 0. For that equation 2, and then substitute 1 into equation 2. Okay, where this and we replace all of this. So it's going to become 12 plus 4b plus 2b minus 3 is equal to 0. This and this, that is a 6b. 12 minus that is a plus 9 is equal to 0. Move the 9 that side, negative 9 over 6, which is the same as negative 2. All right. And then I'll replace this into the first equation to get c. So 2 times negative 3 over 2 minus 3. Simplify that, negative 3 minus 3, which is a negative 6. So guys, b is negative 3 over 2, and then c is negative 6. All right, so that is 7.2. Then question number 8. It's also calculus. These people were 2 genetics. Okay, so during an experiment, the temperature in degrees Celsius varies with time in hours according to this formula. So the function of temperature with difference to time is telling us that, and they're telling us that time is in between 0 and 10. 8.1, Determine an expression for the rate of change. Okay, so when we talk about rate of change, that's more like the derivative. That's what we mean. Rate of change means derivative. It's a component of calculus. So 30 plus 40 minus a half t squared, that is the expression. So which means dt by dt, that's the small t. The capital T by the small t. This is a constant, dies out. This is a 4. 2 times negative a half will be negative 1 with the t. 2 minus 1 is just 30. So that's the t dt is 4 minus t. Okay, 8.2. During which time interval was the temperature decreasing? Okay. During which time interval of temperature? In other words, if we get the derivative, okay, the capital T, the small t must be less than 0. So the rate must be less than 0. So all we have to do is just substitute our 4 minus t is less than 0. Okay, so we can make t the substitute, we can divide through by negative so that the t is positive. We can move this side. Does it make sense? Yeah. So we're gonna say negative t is less than or equal to negative 4. Divide both sides by negative 1. When you divide through a negative sign into an inequality, the symbols must change so that is greater or equal to 4. Now, during which time interval? Remember, this is just an answer. So from the conditions they gave us that t is between 0 and 10, they're telling us here from our answer that t must be greater or equal to 4. So we're gonna say that 4 must be the minimum. Okay, but the maximum must be. Okay, guys, so that is question number 8, and I see that total mark is 120, so that's where we stop. All right, this is information sheet, okay. Guys, thank you very much. Let's meet within paper 2.